This is Professor Pelton. This is part 2 of chapter 5, section 5. So in some cases you could get multiplicity, you could get the same answer or the same zero more than once. So once you do a zero, you check it over and over again to make sure it doesn't come out. So we'll make our list of possible answers and we'll go from there. Actually, move this down a little bit more. Okay, so the constant in this case is 2, so P is 2. And the leading coefficient is 4. So the factors of 2 are 1 and 2. The factors of 4 are 1, 2, and 4. So the possible list of answers are plus or minus, let's see, so 1 over 1, 1 over 2, 1 over 4, 2 over 1, 2 over 2, 2 over 4. Okay. All right. So you can go through and check with 1 and -1, it won't work. You'll check a half, it won't work. So if you go to -half, that actually will work. So again, only list the ones that actually work when you actually do these problems. So 4, -8, -3, 5, and 2. Okay, perfect. All right, so we're going to add. They're going to multiply. We're going to add. Then we're going to multiply. And we're going to add. Again, we're multiplying by the -1/2, so we're going to multiply. We're going to add, and then we're going to multiply. So perfect, that works. Okay, so f of x equals x plus 1/2, because if I solve that, I'll get -1/2. And then 4x minus 10x plus 2x plus 4. So the original problem was fourth. So now this one is 3, 2, and 1, since we took one x factor out, essentially. Okay, so again, always check the same one again. So if I check -1/2, again, so we'll do 4, -10, 2, and 4. Okay, let me write that half a little bit better. And again, don't just move on to the next number in the list. Make sure you keep checking that same number over and over again until it no longer works. So I'm going to add, I'm going to multiply, I'm going to add, I'm going to multiply, I'm going to add, and I'm going to multiply. Oh, look at that. Works out perfectly. All right, so the function is now x plus 1/2, and then another x plus 1/2. So we have multiplicity, essentially. And then 4x minus 12x plus 8. Okay, and this was a third power, right? So now I'm left with 2 and 1. Okay, so we can rewrite this. And I notice I have a common 4 I can take out of here. So if I take out the 4, I'm left with f of x equals 4x plus 1/2 squared. Okay, so I'm left with x squared minus 3x plus 2. Okay, so here's the problem. If I do the factors now, 1 and 2 gives me 2. The factors of 2 are 1 and 2, or -1 and -2. Neither one of those, actually no, the -2, -1 will work, won't it? Okay, so we can actually factor that. So f of x equals 4. So we have x minus 1/2 squared. So we have 1x. Let's make it better squared than that. Okay. So what did I say? -1, -2? So -1 and -2 will actually work. Perfect. So those are the factors, right? So 0 equals 4. X minus 1/2 squared, x minus 1, x minus 2. So those are the factors, right? Okay, so the zeros are x is 1/2, 1, and 2 if you solve all of those. Okay. All right. So I think we're good there. All right, pause the video. Try the student problem for yourself. And again, you could have kept going with the synthetic if you want to, but once you get down to a quadratic, it's just easier to solve it by algebraic methods instead of doing synthetic. Again, to repeat, you can keep doing synthetic all the way, but once you get down to a quadratic, you shouldn't for a variety of reasons. All right, so let's try this one. So here, the constant is 4, so P is 4, and the coefficient is 9. The factors of 4 are 1, 2, and 4. The factors of 9 are 1, 3, and 9. So the possible answers, the possible zeros, are plus or minus. So we'll do 1 over 1, 1 over 3, 1 over 9, 2 over 1, 2 over 3, 2 over 9, and then 4 over 1, 4 over 3, and 4 over 9. Okay, so those are all the possible answers out of infinite number of numbers. So it narrows it down. Okay, so we'll just start with 1 and -1. So we do a -1. So we'll see if -1 works. Okay, so we're taking out, what's it, 9, 6, -11, -4, and 4. So we're going to add, then multiply. 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 Okay, so that worked. So f of x is x plus 1, because if I solve that, I'll get -1. And then 9x minus 3x minus 8x plus 4. All right, so let's see. The original one was a 4th powers. Now this is 3rd once we take 1 out. All right, so we'll do this again. We'll check -1 again. So 9, -3, -8, and 4. Okay, so we're going to add, then multiply by -1. We're going to add, then multiply by -1. Then we're going to add, then we're going to multiply by -1, and that works. So f of x equals x plus 1, and now another x plus 1, or you can just write x plus 1 squared, and then 9x minus 12x plus 4. Okay, well this was a 3rd, so now we're going to be left with 2, then 1. Okay, so I'm trying to think, nothing in common there as far as factors goes, so we'll factor this now, so 9, so we're left with x plus 1 squared, so 9x all over 9. So 9 times 4 is 36, right? So 36 is 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, or the negative options, obviously. So negative, 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 and negative, negative. Okay, so what I'm trying to get is -12, so double 6s will work for us. Looks like each of those have a common factor of 3 that can come out. So I'm left with f of x equals x plus 1 squared. And then a factor, what did I say, 3? Yes, 3. So times 3 is 3x minus 2, correct? Be the same thing with the other one. We'll take a 3 out. So 3x minus 2. And there's a 9 on the bottom, which now cancels. So we're left with f of x equals x plus 1 squared, and then 3x minus 2 squared, right? So if I set it equal to 0, I can get the zeros, right? So these are the factors, right? Factors, which have multiplicity. So the zeros are x equals -1 and 2/3. We'll think about it, because 3x minus 2, if you solve it, right, you get 3x equals 2, or x equals 2/3. Okay, Pause the video, try the... Oh, I'm sorry, that was a student problem. We're on the next page now. Okay, so all of these so far have had all of the answers in the actual table that we made. But what if you had some irrational answers, which could happen, which means you're going to have to do the quadratic formula or some variation of that when you get down to the last step. Okay, so which is fine. So start with your irrational answers, and then you'll find the irrational answers in the end by solving with the quadratic formula. Or something they're like. That's why you don't want to, once you get down to a quadratic, that's why you want to stop doing the method with the P and Q list because of that fact, because they might not be actual rational answers. Okay, so P in this case is 6 and Q is 3. So my factors are 1, 2, 3, and 6, and my factors are 1 and 3. So my possible answers, P and Q, are 1 plus or minus 1 over 1, 1 over 3, 2 over 1, 2 over 3, 3 over 1, 3 over 3, and let's see, oh, the 6s. 6 over 1 and 6 over 3. Again, there are repeats in here because obviously 6 over 3 is the same as 2 over 1. Okay, so you want to be able to pick out something from the list a little bit easier. So one method you could do is use the calculator to estimate where the answers might fall. So we'll take this here and we'll make a graph. So what do we have for a function? We have 3x to the 4th power, and that gives you minus 8x to the 3rd minus, minus 9x squared plus 16x plus 6. Okay, so it appears it looks like it goes through 3, and I'm thinking negative 1/3, and these ones look kind of weird, so I'm not sure. Those might be the irrational ones, right? I'm not really seeing anything in my list that represents that, because it's like 1 point something. I don't see those in there if you look at my list. Okay, so I think based on the graph where it goes to the x-axis, because the zeros are the x-intercepts, I'm thinking negative 1/3 was one of the answers. We'll find out by doing it this way. So we have 3, negative 8, negative 9, 16, and 6. Okay, so that's good. So we're going to add, then multiply. We're going to add, and then we're going to multiply. So that would give me what, 3? We're going to add, and then we're going to multiply. So that gives me let's see, 1/3 of 6 is 2. So we're going to add is 18, and then 1/3 of 18 is 6. That actually worked. Perfect. Okay, so f of x equals x minus, or x plus 1/3 gives me negative 1/3, right? And we have 3x minus 9x minus 6x plus 18. The original one was a 4th power. I took one out. Now I'm left with 3, 2, and 1. So I believe I remember correctly from the calculator when I was graphing it. It looks like 3 was an x-intercept, so I'm going to try that one next. So 3, negative 9, negative 6, and 18. Okay, so I'm going to add, and then multiply by 3, I get 9. I'm going to add, multiply by 3, I get 0. I'm going to add, then multiply by 3, I get negative 18. Oh, that worked. Perfect. All right, so f of x equals x plus 1/3, and then x minus 3 will give me 3. Then I'm left with 3x squared plus 0x minus 6. I think we're good. All right, so if I think about it, 3 times 6, that would be, or negative 6 is negative 18, correct? So if I do 18, I get 1 times 18, 2 times 9, 3 times 6, and one of these needs to be negative. But either way, none of those give me 0, so that's not going to be. So you use a quadratic formula or just solve it individually. Okay, I think in this case, we'll solve it individually. How's that sound? Okay, so if I solve this individually, 0 equals x minus 1/3, and then I have x minus 3, and then I have 3x squared minus 6. Okay, so if I solve this over here, 3x squared minus 6 is equal to 0. So 3x squared is equal to 6. So if I divide by 3, x squared is equal to 2. So if I square root, x equals plus or minus root 2. Okay, that'll work. If you do the quadratic formula, you get the same thing. But since it was a 0 term in the middle, that seemed to be the quicker option. Okay, so my factors are x minus 1/3, x minus 3, x minus root 2, and x plus root 2. Okay, that's not very good. We'll fix that root in there. So these are the factors, even though my root. So my zeros, put the dots here. X equals, what do we have? 1/3, 3. Oh, I messed up. That's a plus. I'm sorry. That's a plus. That's a plus. That's a minus. Then we have root 2 and negative root 2. Sorry. Okay, pause the video. Try the student problem for yourself. Again, after you make your list, use the calculator to help you decide on the proper ones to use. All right, so P in this case is 1, and Q in this case is 2. Okay, so the factors of 1 are 1, and the factors of 2 are 1 and 2. So the actual list is pretty short this time. It's 1 over 1 and 1 over 2. So there's not a lot of answers there that are possible for rational. And it says there's 4 answers since it's the fourth power. So if I look on the actual calculator, it looks like it goes through 1/2. So we'll prove that's true now. So 2, -7, -3, 5, and -1. Okay, so 2 times 1/2 is 1. So if I add those, I get -6 times 1/2. Excuse me, I get -3. Add those, I get -6. Multiply by 1/2, I get -3. Add those, I get 2. Half of that is 1, and that works out. So f of x, I don't know why that keeps happening. So f of x equals x minus 1/2. That'll give me 1/2 when I solve it. 2x minus 6x minus 6x plus 2. The original problem was 4, so now we're down to 3, 2, and 1. Okay, so I noticed that it goes through -1 on the graph, so I'm going to do that. I'm not going to check 1/2 because it doesn't bounce off the graph. Okay, so if it bounces off the graph, it's going to be probably twice. You know what I'm saying? Look, refer back to the graphing what we did in the prior section. All right, so 2, -6, -6, and then 2. So I'm going to add and then multiply, and I'm going to add and then multiply. I'm going to add, then multiply by -1, and it worked. Okay, so f of x equals x minus 1/2, and if I do x plus 1, that'll give me 1, and I'm left with 2x minus 8x plus 2. Since I was doing third power a second ago, now I'm down to 2 and 1. So I notice those have a common factor of 2 I can take out. So f of x equals 2, x minus 1/2, x plus 1, and then x squared minus 4x plus 1. Okay, so what you notice, the problem is here, if I do 1 times 1 and get 1, right? I get 1 times 1 or -1 times -1. Neither one of those give me -4. But so I'm going to have to do quadratic formula there since the middle term is not 0 in this case, right? So x equals -b plus or minus the square root of b squared minus 4, and then AC all over 2A, right? So you get your, let me erase this over here on the bottom. As we tried to factor, but it's not factorable, which means it's not a rational answer. That's A, that's B, and that's C, right? 1, negative 4, and 1, okay? Because if something's not factorable, it's not a rational answer. It must be an irrational answer, hence why I have to do the quadratic formula, right? All right, so x equals 4 plus or minus the square root of, that'd be 16 minus 4, so that's 12 over 2. So that's, oh, I don't know why I made that so long. So that's 4 over 2 plus or minus the square root of 2 times 3 over 2. So x equals 2 plus or minus 2 root 3 over 2, which is 2 plus or minus root 3. Okay, so f of x equals, we had what, 2 and, oh shoot, I gotta write the 2 first. X minus 1/2, right? X plus 1, and then x minus 2 plus root 3, and x minus 2 minus root 3. Okay, so those are my factors. So my zeros, x equals 1/2, negative 1, 2 plus root 3, and 2 minus root 3. That's not very good. Okay, so notice the first two answers are actually in the list because they're rational. The second two answers are not in the list because they're irrational, because the P over Q are only the rational answers. Okay, so make sure you, when you get down to a quadratic, you don't do the P and Q method anymore because of the fact that the last two answers might be irrational or imaginary. That's the end of part 2.